What's going on, everybody? What's going on, everybody? Jeez. Uh, Taking a look here at this golf ball problem. We've already previously taken this, plugged in the table into Desmos using the table app there on Desmos. I decided to, for comparison's sake, take down the quadratic and the cubic models here. So you can see that the quadratic and the cubic models underneath. Just kind of for comparison's sake, we'll see how they each do. So I have up here the graph we should already have from Desmos, and I do have both quadratic and cubic models to check out here. So let's go ahead. It does say quadratic on the top and then cubic afterwards. So let's go ahead and see if we can answer some of these questions. Use the model to estimate the height of the hill. Use the model to estimate when the ball hits the ground. And use the model to estimate when the ball gets to its maximum height. What is the maximum height? So we'll go ahead and we'll take a look specifically here at the quadratic model. We'll see eventually in another video how it matches up with the cubic. So let me go ahead and highlight this. It's going to be red, just for argument's sake. Later on, blue is going to be cubic, but we'll focus on the red here. So first and foremost, I believe the question says the hill. That's where we're starting. So we need the y-intercept here, and we're going to go with 11 for our y-intercept. So the estimated height of the hill in meters is going to be 11 meters. Next, we want to figure out the estimation for the ball hitting the ground. We want to have, and again, if I just click on the graph, these things, certain pieces of this just pop up for me. 5.31 is our x-intercept, 5.31, and that is in seconds. For quadratic, 5.31 seconds is the estimate when the ball hits the ground. Finally, use the model to estimate when the ball gets to the maximum height. What is the maximum height? And I'm going to highlight this right there. 2.552, I'll round it just for argument's sake. 76.6 meters. So at 2.55 seconds, push out of the way there, we get 76.6 meters is the height, the maximum that the ball hits. Let's go ahead and take a look at the cubic model now and compare it to the quadratic. So here's our cubic. Again, if I just click anywhere on the graph, it gives me a bunch of these points already, which is lovely. 13.24 for the y-intercept. So a slightly taller hill in this scenario. If it was something ridiculous, if it was a negative number, we would know that we would not, in fact, be on the hill, and we'd be able to kind of get rid of that model. It's not the case here. Estimate when the ball hits the ground. Let's see what it says here. 5.3, very, very close. Put it to the 100th there. For when the ball hits the ground. And finally, a max height and what time it is. 2.57 seconds. 76.4 meters, 2.57 seconds. We get to 76.4, had that backwards, meters. All right, so we could see here, and we understand this because of our R squared being 0.9999 for the quadratic, then 1 exactly for the cubic, that we have two models here that fit this data very well. And regardless of which one we pick, we're going to be awfully close in both of these situations.